we are starting talking about inequalities, and we just talked about inequalities kind of in general in 4.1. So now we're going to move on to solving inequalities using addition and subtraction. So first I have a couple properties that we need to talk about. So the first one is the addition property of inequality. So my addition property of inequality, all that says is when you add to one side of the inequality, you need to add the same number to the other side. To the other side. And the reason why, right, is if I only do it to one side, then my equation changes. It's not balanced. So I started with one inequality. If I add something to it but don't add it to the other side, I've changed the inequality, and I don't want to do that. So that's the addition property of inequality. Subtraction is the exact same thing, just with subtraction, right? So when you subtract from one side, you need to subtract from the other side. For the same reasons, right? Subtract, same number from the other side. Okay, so that's pretty straightforward, right? Another note to just remember is that we solve inequalities the same way that we solved equations last chapter. So we just got done talking about how to solve for equations, how we solve for variables. We're literally doing the same exact thing. It's just that instead of having an equal sign, we have an inequality. So my whole goal is to get my variable by itself. So let's look at this first example. X minus 5 is less than negative 3. My goal is to get x by itself, so I need to use inverse operations in order to do that. So I have x minus 5. In order to undo that, I need to add 5 to both sides. So I'm going to add 5 to both sides. So then I have that x is less than negative 3 plus 5 is going to be a positive 2. And I can stop there because I have x by itself related to a number. So now I need to graph it. I'm going to put my number line over here. Let's put a 0 in the middle. 1, 2, negative 1, negative 2. Am I going to put an open or closed dot on 2? If you remember, right, I'm going to do an open dot. My open dot tells me that I'm not including the number 2. So I'm starting there, but I don't include it. X is less than 2, so that means that my arrow is going to point to the left. Oof, that was not a good line. My arrow is pointing to the left. X is less than 2. If we look at the next one, x minus 2 is greater than or equal to negative 4. So same thing, I need to undo my subtraction, so I will add 2 to both sides. I get that x is greater than or equal to negative 2. I'm going to graph this one too. 0, 1, 2, negative 1, negative 2. This time I have greater than or equal to. Because of that, I'm going to use a closed dot because I am including negative 2. Greater than means that I'm going to point my arrow to the right. Ooh, hello. To the right. Okay. Great. This should feel pretty simple. Like you should feel pretty good about this. The last one here, this one's kind of a little bit trickier. So I have negative 1/2 is greater than x minus 1/4. Well, the first thing that I want to think about is I want a common denominator. I see fractions. I know I'm going to have to do something with them. I want to find a common denominator. This one's pretty simple, right? Because my common denominator is just going to be 4. So I could rewrite this as negative 2 over 4, it's the same thing as 1/2, is greater than x minus 1/4. Now I'm going to add 1/4 to both sides to get rid of it. I have negative 2/4 plus 1/4 is going to give me negative 1/4. So I have negative 1/4 is greater than x. Get my graph out here. Okay, so this is kind of where the tricky part comes in. This trips a lot of people up, and so we're going to spend some time practicing it. Negative 1/4, negative 1/2, negative 3/4. Okay, so I have that negative 1/4 is greater than x, and if you remember, right, we talk about the alligator eats the bigger number. So in this case, negative 1/4 is bigger than x, right? It's eating the bigger number. Well, all of my other inequalities have had my variable on the left-hand side. But this time it's not. But I kind of want it to be on the left-hand side because it's a little bit easier to know what I need to do. So if I put my x over here, I have my negative 1/4 over here. I need to figure out how they're related, right? The alligator eats the bigger number. I know that this is the bigger number. So x is less than negative 1/4 is the same thing as saying that negative 1/4 is greater than x. So this is just a less than sign. So I'm going to use an open dot, and I'm going to point my arrow to the left because it's less than. A lot of people, when they look at this, they'll get to this part of our equation, and they'll say, oh, well, I put an open dot on negative 1/4, and then it points to the right because it's a greater than sign. But that's not the case here, right? I actually am going to point my arrow to the left because x is actually less than negative 1/4. And that's a little less obvious to see. Ooh, okay, so, come on. We have the same thing with addition, right? I'm just going to show you one of these, and then I would like you to just complete the rest on your own. So I have 13 is less than or equal to x plus 14. I want to get x by itself, right? So the way that I'm going to do that is I'm going to subtract 14 from both sides so that I can get rid of it. 13 minus 14 is negative 1. So I have negative 1 is less than or equal to x. Using what we did before, I'm going to rewrite this as x is greater than almost, come on. X is greater than, goodness sakes, x is greater than or equal to negative 1. Oh goodness, okay. All right, x is greater than or equal to negative 1. Right, these say the same thing. My inequality, my alligator is still eating the bigger number. They say the same thing, they're just written in a different way. So then when I graph this, I can have, let's do 0, negative 1, negative 2, 1, 2. I'm going to have a closed dot at negative 1. X is greater than or equal to negative 1, so it's pointing to the right. Okay? I would like you to go ahead and do the other two on your own. And we're going to move on to this. So you can go ahead and pause this to work on them, or you can work on them when we're finished here. Okay, a real life application. A person can be no taller than 6.25 feet to become an astronaut pilot for NASA. Your friend is 5 feet 9 inches tall. Write and solve an inequality that represents how much your friend can grow and still meet the requirement. So the first thing that I need to do is set up an inequality. So I have to be less than or equal to 6.25 feet. So I know that the biggest I can be is 6.25 feet. So I need to be less than or equal to that. This is the biggest I can be. Right now, I'm 5 foot 9 inches. So let's figure out, what is that as a decimal? Let me pull up my calculator so you can watch me do this too. So I have that my friend is 5 foot 9 inches. Well, I want to know how much of a foot is 9 inches. So I would have 9 divided by 12, because there's 12 feet in an inch. Okay, so 0.75. So my friend is 5.75 feet tall. Oops. I'm going to add to that however much more they can grow, and that needs to be less than or equal to 6.5. 6.25, excuse me. Okay, so then I'm just going to solve this, right? So I'm going to subtract 5.75 from both sides. Maybe, if my board will let me. Subtract 5.75. Subtract 5.75. I'm left with x over here is less than or equal to 6.25 minus 5.75 will give me 0.5. X needs to be less than or equal to 0.5. In terms of inches, what that means is that x needs to be less than or equal to 6 inches, half a foot. Okay, my friend can grow at most 6 more inches before they could no longer be a pilot for NASA. Okay, everything else in here is a practice worksheet for you. So there's a whole bunch of practice problems that I would like you to do. So the first two is going to ask you to write an inequality that makes it true. So look at, is it an open or closed dot, and which way is the arrow pointing? The next one is having me write a word sentence as an inequality. So you're going to want to have out the notes that I gave you about what each inequality goes with what words, because that will help you out a lot. So for this first one, right, a number x is at most 3. So I would look and see, okay, the words at most fall under the less than or equal to sign. So a number x is less than, is less than or equal to 3. That's my inequality for the first one. Go ahead and do the next 3 on your own. This section is having you tell whether the given value is a solution to the inequality. So the way that I do that is I'm just going to plug my number into the equation. So it wants me to look at t minus 3 is greater than or equal to 2. I want to know, is this true when t equals 10? So all I have to do is plug in 10. So I would be 10 minus 3, is that greater than or equal to 2? Well, 10 minus 3 is 7. 7 is greater than or equal to 2. So yes, this is a solution, right? The next ones, these just want you to graph those on a number line. You have another word problem that's kind of similar to the one that we just did. And then on the back side, I think I have some more word problems for you. Another plug it in. Another one where it asks you to look at the inequalities and plug some values in for solutions. And then there's kind of a longer word problem that involves you creating multiple inequalities. So I want you to go ahead and take a stab at that, and if you need help, just let me know.